Good morning, students. Look at this. We are on number 1.7. Now, what you don't know, how could you, is this actually is the last video I'm doing of Unit 13, or of Unit 1. Unit 1, wow, Unit 13. There's only 10 units. But it'll be the last video I shoot, but look at over here. We're all done. All 13 videos are done, and they are available for you online at www.nkinfinity.com. All of our videos there. By the way, just in case you're wondering, that N is for my partner in crime, Miss Vicky Newman, and the K is for Krause. And as usual, oh, math class never ends. It's like an infinite amount of time in class. All right, today, kids, I'm going to be called Mr. Key. We're going to just discuss, I know we did piecewise function yesterday, but we're going to do a little bit more with piecewise function because we thought, yeah, maybe you guys need a little bit extra help, one more extra day with piecewise functions. Plus, there's one new function I want to talk to you about. And I will do that in just a second. Anyway, while I am waiting, or while we are... So in my class, what I would do is a little bit of warm-up, and you'll see why I'm having you do this in a minute. I want you to graph these two functions. F of x equals 3. Well, that's a constant function, 3. So I'll just graph in. That's f of x. F of x equals 3. Or how about g of x equals negative 2? That would be down here. Notice they are horizontal lines. And they're very simple to graph, right? You know, that's like a 2-second warm-up in class, long enough for me to tell, I don't know, to do something, I guess. But today we're going to be talking about these things called step functions. Step functions. Hold on, I got something wrong. I'll be right back. All right, step function. Step function is not bad. You'll see what step function. Sometimes this is called a staircase function. You'll see why in a minute when I show you some of my amazing artwork. Staircase function. And basically it's just a piecewise function containing all constant pieces. Okay, so this is just a very simplistic definition of a step function or staircase function. Let's look and see what they look like. Oh, look. They look like steps. Like if I was to draw and go and fill this all in. Yes, don't those look like stairs? They look like stairs, don't they? So that's a step function. All right. You know, if you got your guy over here, I told you I was going to do some good artwork for you. I'm smiling. This is my hair. And by the way, my hair is really long now. I hope in the next couple of videos you see that I actually get my hair cut. I got a little stubble going on the face because I've been a little bit lazy during summer. All right, guys over here going, oh, I get to walk up these stairs. Man, I should have been an artiste. I know that's what y'all thinking. Anyway, they're called, I said it was a piecewise function containing all constant pieces. And what I mean by that is, if you go back up here and look and see what we just graphed. We just graphed constants. This is a constant. This is a constant. It's not changing. G of x will always be negative 2. F of x will always be 3. They are constants. Well, that's what we have up here. We have this function. I'm going to call it f of x for now. But it's got constant pieces. A small constant piece, a small constant piece, small, and it's discontinuous because it's not a graph that looks and flows like this, right? It's got breaks, it's got separations. There's no y values being used here. As a matter of fact, in this particular case, all the y values are integers. Negative 2 is a y value. Negative 1 is a y value. 0 is a y value. So the y values in this case, and we're going to talk about that in a second, the domain and range, are a little bit different. So let's talk about how we write up this piecewise function. It shouldn't be very difficult, but we're going to talk about it because I want to make sure you understand this. So at this point right now, f of x, remember f of x stands for the y values, and I just went through some of the y values. One of the y values is -2. But it's only -2 over a defined interval, and that defined interval is between -3 and -2. So I'm going to do x in the middle, always less thans, -2 and -3. Now you just have to decide if you're going to put an equal to on them. Over here at the -3, I have a solid circle, so I'll put an equal to. But on the -2, ooh man, did I just put those backwards? On the -3 over here, always a small one on the left and the big one on the right. Over on the -2 though, open circle. So we don't put that there. So now you're probably like going, oh, okay, I think I got this. So the next value that y can be, they're discrete numbers, right? -1. And that's from x in the middle, always less thans, small number on the left, big number on the right. And this is from, and we put an open circle here, or closed circle here, so that's equal to. And the next number, f of x could be equal to is 0. And that's from -1 less than or equal to x less than 0. Or it can equal 1. From 0 is less than or equal to x is less than or equal to 1. Or it can equal 2. Sorry, my eyes are going crazy. From 1, oh, I put an equal to here. There is no equal to on this one. Let's get rid of that. 1 less than or equal to x less than 2. And we ended with an open circle here. All right, so I got a couple questions for you. Is this a function? I call it a piecewise function. Is it a function? You should know and be able to test whether or not this is a function. It's a very simple test. It's just called the VLT, the vertical line test. If I draw a vertical line in anywhere, let's do it in blue. No, let's do it in black. If I draw a vertical line in anywhere, did that hit more than 1 point? I mean, if I draw it in here, or draw it in here, and I draw it in here, not hitting more than 1 point. Did I draw it and hit it more than 1 point here? No, because remember, this is not a point. It's like a little tiny hole that vertical line's going through. Again, that vertical line's going through only 1 point right there. It does not go through there. That's like a loop. You know, it's like the Harry Potter goal you got to throw the ball through, right? And I know, I hate Harry Potter. Yeah, I love Harry Potter. Yeah, I drink Dunkin' Donuts coffee too. Anyway, so yes, it's a function. So if I asked you if it was a function, you'd have to say yes, it's a function. Function? Yes. Is it a one-to-one function? Well, does it pass the horizontal line test? Well, no, not at all. See, if I draw a horizontal line in there, I hit an infinite number of points. Yes, an infinite number of points. And they're infinite. So no, it is not a one-to-one function. Therefore, because it's not one-to-one, it does not have an inverse. But let's talk about, more importantly, let's talk about domain and range. I want to talk about domain and range of this thing. Just very quickly, domain. Now remember, domain are the x values. So the lowest x value is -3. So, and it can equal -3, so I'll put bracket -3. And it looks like the highest value is 2. But because it doesn't have because it has an open circle, we're going to have to put a parenthesis here. Now the question is, are there any breaks where there was no x value? So, is there a one here? Yep. Is there one here? Yep. Is there one here? Yep. Is there one at -2? Yeah, it's here. And -2 and negative there. Oh, that. Wait, is there one at -1? Yes, it's right here. And all of these points count. And at 0, yeah, it's up here. And at 1, yeah, it's up here. So there are no breaks from -3 to 2. There's no breaks for the x values. Now the range is going to be slightly different. The range, to describe the range here, it's a little bit odder. You can't use interval notation and you can't use standard or inequality notation because this is not a continuous function. You can't say, oh, it goes from -2 all the way up to 3. And you'd say, oh yeah, I'm using all these values in between. The problem is I'm not using any values here. Like I can't say, oh, what's the x value when y equals -1.5? Well, y never equals -1.5. There's no part left or right at -1.5. There's no here at 1.4 or at 0.4 or at 1.1. There's no y value. So they are discrete numbers. They are only certain numbers. So the range, if I'm going to describe the range, I've got to list it as a set of points. And there are 5 points that y can be. It could be -2. It could be -1. It can be 0. It could be 1. And it can be 2. So watching and describing the range of a step function is a little bit different. You have to be very careful. The domain can be described as a continuous amount as long as there's no holes. If there's holes, you got to do something different. But the range has to be described using a set of values. All right, let's do a couple more examples. Here's another piecewise function. So let's see. Remember, f of x are the y values. All right, so let's take a look. What is the first y value can be? The first y value it can be is 5. And that's from -4 to -1. -4 less than x less than -1. Now, at -4, I have an open circle, so I'll leave it as less than. But at -1, I have a closed circle, so we'll put this as an equal to. The next value this function can be is 3. And that's from -1 to 2. So -1 less than x less than 2. But at 2, we have a closed circle, so we'll put it equal to. And finally, the last value is 1, and that's from 2 less than x less than or equal to 5. So if I was to say, is this a function? Yeah, it's a function. It passes the vertical line test. Again, remember, if I draw this vertical line in, it's only hitting one point. It only hits this point. This one, it goes through. It's like an opening circle. All right. So yes, it's a function. No, it's not a one-to-one function because it fails the vertical line test. Let's talk about domain. Domain. Are there any breaks left or right? Let's see. From -4, no breaks. No breaks. So domain's pretty easy. It's from parenthesis -4 all the way up to 5 bracket. But the range, remember, the range is not continuous. It's got breaks. So we have to list it in curly brackets. And the range values are 5, 3, and 1. So 1, 3, 5. We just list them in numeric order. All right. Moving on. Oh, now we have to be able to go back and forth. So let's see what we have here. We've got 3 values. I've got a mistake here. This should not be -4. I'm going to fix that. On yours, it'll be fixed. It should not be -4. It should be that should be a 2. Sorry, I don't know why it's not. That's weird. Hope I didn't make that mistake again. All right, 2. So yours will say 2 there, and you'll be like, oh, mine already says 2. So let's see what we got here. F of x could equal -4. So if I just drew this, if none of this was here, none of that was there, and I just said f of x equals -4, I would draw this line in right here. This is the line f of x equals -4. But I don't want that whole line. The directions for this one said I can only graph that from -6 to -3. I can only graph it from -6 to -3. So here's -6. Put an open circle there. And here's -3. We'll put an open circle there. I only want this piece. I don't want that whole thing. So let's get rid of those. And maybe I'll draw better circles around. I didn't like this circle very much. And that one's all right. And then I only want this piece right here. Now, is one of these a filled in circle? Oh yeah, -3. I got to fill it in. Okay. So f of x equals -1. That's this line right here. But I don't want that whole line. I only want from -3 to 0. From -3 to 0. So I don't want this whole line. I know, you wish you could erase like that. And we'll fill in at 0. And 2. Well, here's the line 2. But I don't want that whole line. I only want from 0 to 3. So we'll get rid of that line. And we'll fill that in. And at 3, we have a filled in circle. Yes, it's a function. No, it's not a one-to-one function. The domain is from -6 to 3. And the range is, it's a set of values. It's -4, -1, and 2. Okay, it's at this point I am going to ask you to try it. It's your turn to try what we're doing, what we're working on here. So, pause this, see if you can create this diagram based on this information, and then unpause it. So, and then at the end, see if you can write the domain and range for me. Can you write the domain and can you write the range and tell me what those are? So pause it. Hey, welcome back. That's awesome. All right, so hopefully you graphed this correctly. So we want 1. I'm not going to draw this 1 in. I'm only going to draw this 1 in from -2 to 1. So from -2 to 1. Oh, not 1, not +1, not -1, +1. So from -2 to +1, it's equal to 1. Now, do I fill in one of the circles? Let's see, I fill in at 1. Then it's equal to 0 from 1 to 4. Oh, this is 0. 0 from 1 to 4. So we'll fill in that circle. I know that's kind of hard on yours because it's a dark line already. And we fill in the 4. And finally, it's equal to -1 from 4 to 7. So, how'd you do? Did you write the domain or range? Stop for a second. Write the domain and range. You should have paused it while I was doing that. All right, so the domain is from -2 to 7, bracket here. The reason it's from -2 to 7, just a reminder, here's -2, here's 7. It's continuous the whole time. And then we never break. We never lose an x value. All x values are being used. But remember, the range is slightly different. The range is only going to be a discrete values. It's -1, 0, and 1. All right. Now it's your turn to work backwards. So the easiest way to handle this is just first figure out what are all the y values I can use. Oh, I can use -4. I can use 2. And I can use, what's this y value? What is this y value right here when we're on this axis, huh? Oh, by the way, you should have paused this. Go ahead, pause. My best Bill Clinton. I can't do that. Anyway, -4, 2, -2, and 0. Those are all the values that y can be. So those are all the values for f of x. I don't know why I keep using f of x. I should have gotten more imaginative and called them g of x and h of x and p of x and q of x. And most importantly, k of x for Krause. All right, so now we just got to figure out where is it? Where is it -4? Oh, it's -4 starting out here at, let's see, that must be -7, right? So starting at -7, less than x, less than -3. And I've got the closed circle here at -7, so I'll put an equal to. Where is it -2? Well, it's -2 starting at -3, less than or equal to x, less than 1. And where is it 0? It's 0 starting at 1, less than or equal to x, less than 5. Write the domain and range. Okay, domain. Domain is easy. It's from -7, bracket -7, because that's over here, all the way over here. 5. Parenthesis. But remember, ranges are discrete values. They're just like individual values, and those are -4, -2, and Zippo. I think we got 2 more problems. We got 2 or 1? 2 more problems. Yay! Okay, so now I've decided to mix a little bit of what we did yesterday with today's stuff, and let's just do it. Let's do 2 more practice examples, and then you can probably get started on your homework. All right, so now we've got to go back to being a piecewise function. So let's see here. I got to first talk. This is 1 piece. This is 2 pieces. And this is 3 pieces. So this one's probably the easiest. Piece 3 is probably the easiest because it's all set up for me. It's got a slope of up 2 over 1. So that's going to be 2x. And it goes to the point -1. But what is its values? Its values are from -2 to 2. So -2 less than x less than 2. And I have an open circle here, so I better put an equal sign. All right, that one wasn't bad. 2 is pretty easy too. Piece 2. This is piece 2, remember. That's pretty easy too. What is that y value right there? Remember, that's a horizontal line, so what's that y value? It's a constant y value there, and that value is 0. And that goes from -3 to -2. So from -3 is less than x is less than -2. It's got the equal to right here. One's a little bit more challenging. I can do the slope. First of all, it's coming down, so it's negative. So I know the slope is negative. And it's going down 2 and over 3. So my slope is -2/3 x. Now, I got to figure out what the y-intercept is. So if I go down 2 and over 3 again, it would end up there. So if I continued this line, it would go through that point 0, 2. So that would be +2. And that piece 1 is from -6 to -3. -6 less than or equal to x less than -3. What's the domain and range? Just for fun. Domain. Ooh, man. Domain starts at -6. Let's see. -5, -4, -3 it's down here. -2, yep. -2 it's down here. And it goes all the way over to 2. So it goes from -6 to 2 with no breaks, but we can't include 2. Now, the range is a little bit freaky deaky. This range would be very difficult to write. Not very difficult, but you got 3 pieces. You have some continuous pieces where you have a nice line that's going to include all these values from 6 to 4. So that's your first piece. Bracket 6 to 4 doesn't include 4. 0, this piece right here is 0, but 0 is also included in this piece. So 0, it could be 0 either here or here. So I'm just going to include it on that one. So union from -5 to 3. -5 to 3. And that would be the range for that value. Ooh, man, that's crazy. All right, last problem. You get to write one on your own. Or you get to create one on your own. There's a lot of stuff going on there. All right, so let's see. We're going to equal 5 from -7 to -3. So let's go find 5. Y equals 5 right here. This is where y equals 5. But we can only go from -7 to -3. Does one of them give a bracket or a filled in circle? Look, -3 gets a filled in circle. Okay. The next 2 are going to be lines. Let's see what we got here. We'll do this in blue. So this is my line, -2x. I'm going to just graph that line. I'm going to graph that line in light blue. So let's graph that line in light blue. It's got a y-intercept of positive 3. And the slope tells us to go down 2 and right 3. So down 2 and right 3. And we'll go up. So that would be that line. Now, if I graph that line, it would be I would connect all those points. But I only want the points starting at negative 3 and going to positive 3. So this one over here, this one right here, that's negative 5. I don't want that one. That's too far away. I do want this point. That's negative 3. I do want this point. That's 0. This point's 3. But I don't want this point right here. So we're going to get rid of that point. And at this point, it should be an open circle. But because that purple's already there, it's closed. So we're okay with that. And are we closed over here? No, this is an open circle over here. So I got to be careful with this one. This one has to be an open circle as well. So this has open circle on both sides. All right. Now we're going to use the line 3x minus 6. Right there. Let me do a different color. We'll go black. So my y-intercept is negative 6. And we're going to go up 3 over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. Oh, man. I'm going to have to change this to a 4. I gave you the wrong graph paper. Actually, I'm going to change the graph paper. So probably no, I'm not. I'm just going to change it to a 4. I'm just going to change this to a 4. So when you have your sheet, this should be a 4. Sorry. Anyway, all right. So let's see. I only want values from 3 to 4. I had 5 only, but my graph was bigger on the test thing I did. So this is x equals 0. I don't want that. This is x equals 1. I don't want that. This is x equals 2. I don't want that. All I want is from 3 to 4. So I want here. Now, 3 has a closed circle, but at 4, it should be an open circle. So I got to be careful. I want to make sure that's an open circle. Open circle. Ready for the domain and range? All right, here we go. Domain. Domain's not bad. Domain, the leftmost value is down here at negative 7. And it's got an open circle, so I got to use a parenthesis. Negative 7. And follow along, follow along, follow along. Oh, can it be equal to 3? It's got an open circle here, but it's got a closed circle there. So it can be equal to 3. So all along here, it can be all these values, all these values, all these values, even 3, and then all of these values. So it goes all the way up to 4. And it does not include 4, so we put an open circle, a parenthesis there. So we have a parenthesis at the beginning and a parenthesis at the end. Now the range is going to be a little bit weird. A little bit weird on this one. Okay, so let's see. The lowest y value I can have, let me do range, let me show you this. The lowest y value I can have for y is 1. So my lowest y value is 1, so range. But it can equal 1, so 1. Now, can it equal 2? Is it all these values? Yep, all these values going up. I should pick a different color, green. It's all these values going up. Yep, 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 yep. Even at 4, it's here and it's here, so that's okay. At 5, yep, 5. Goes all the way up to 5. Can it be equal to 6? Yeah, it's over here. Can it be equal to 5.5? Can it be equal to 6? So there's no break. You know, we change from, that was my silly phone. We're going to change from this graph here to this graph here after 5. But at 5 is there a y value 5.1? Yeah, it's over there. Is there a y value at 5.9? Yeah, it's over there. Is there a y value at 6.5? Yeah, it's over there. So this goes from 1 to 7, parentheses. So let me see if I can. I knew I'd do that. So this should be bracket. This should be. The lowest y value is here is 1, and the highest value here is 7. And from here to here, there's always a point on the graph. So there's our y range. All right, kids, there it is. Yay! Oh, it was fun. Hit the subscribe button and stay subscribed to me, please. Hit the like button. Tell me that you like me. Anyway, if you got comments, leave some comments. Again, all of this stuff can be found at, you can go to www.algebra2commoncore.com too. That'll take you to NK Infinity. And all this stuff is available there. All right, kids. Catch you on the flip side. Bye.